Forensic investigation relies on a simple, linear rule of physics. Cause always precedes effect. By tracing the timeline of an event backward from the final outcome, we can find the specific action that started it. In quantum physics, that outcome looks like a single photon hitting a detector and leaving a distinct, measurable mark. But when we try to find the cause of that mark, the timeline breaks. In the classic double-slit experiment, if the light is unobserved, it behaves like a wave. It passes through both slits simultaneously, interferes with itself, and creates a striped pattern on the back wall. However, if we observe the light by placing detectors at the slits, it behaves as a discrete particle. It passes through only one slit, and those stripes on the back wall snap into two solid clusters. Standard physics suggests that the presence of a measuring device at the exact moment the light passes through the slits dictates whether it travels as a wave or a particle. In 1978, the physicist John Archibald Wheeler devised an experiment to test if this sequence of events must follow a fixed forward-flowing timeline. He proposed a loophole. What happens if the observer waits until the photon has already passed the slits before deciding whether or not to measure it? In Wheeler's setup, the photon is fired, and while it is mid-flight, the observer makes a choice. At the last possible second before impact, they randomly decide to either insert or remove a measuring device. The results show that the photon hits the screen, matching that last-second choice. If the observer decides to measure its path at the end, the photon behaves as if it had been a particle back at the slits. The timeline scrubs backward, and the photon's history changes. This suggests that a choice made in the present reaches back to dictate a physical event that already finished. Observation reaches back into the past, assigning a specific history to a particle that had no definite state until the measurement occurred. To see how far this retroactive effect can reach, we have to move beyond the lab and look at the scale of the universe itself. We can use the universe as a giant interferometer. Light from a distant quasar travels toward Earth, but a massive galaxy sitting in between acts like the double slits, using its gravity to bend and split the light around it. This light began its journey toward us billions of years ago, long before the Earth existed. This image shows 4 distinct points of light from that lensed quasar. Astronomers today can choose to observe this ancient light by aiming telescopes to detect the specific paths around the galaxy, measuring particles, or they can combine the light to measure interference, measuring a wave. Wheeler realized that the choice astronomers make tonight determines whether that photon took one path or 2 paths around the galaxy a billion years ago. A decision made in the present has just finalized a physical event that took place in the deep cosmic past. Modern quantum computers, like the IBM Quantum System 2, have moved these concepts from thought experiments into physical proof. One proof involves the quantum eraser. In this setup, the path of a particle is recorded by a machine, but that data is then permanently destroyed before any human can see it. When that path data is erased, the particle reverts to its wave-like state, and the interference pattern reappears at the detector. Because the interference pattern only returns when the information is destroyed, it reveals a specific rule. The universe doesn't commit to a single history unless a permanent record of that history exists. Without that data, the past remains unwritten. This raises the ultimate question. Does human choice actually travel backward through time to physically change an event? To explain this strange phenomenon without breaking causality, the physicist John Wheeler used a famous metaphor called the Great Smoky Dragon. We can see the dragon's tail, the emission of the photon, and we can see its mouth, the final detection. But the body of the dragon is a haze of undefined probabilities. The past isn't being rewritten because until the measurement happens, there is no definitive past to rewrite, only a set of potentials. Wheeler called this the participatory universe. In this view, we are not simply witnessing a pre-existing reality. Our measurements are the mechanism that forces the universe to materialize into a concrete